Imagine an ant 100 times larger than the one we know, overnight. A colony of black garden ants contains around 5,000 to 15,000 individuals. The average garden ant is about 3 millimeters long, but it can carry 50 times its own body weight. It moves in colonies, it communicates through chemical trails, and it is never alone. But ants are not the only problem. Mosquitoes would become flying predators the size of birds. Cockroaches could crawl through ventilation systems and survive almost anything. Spiders would stretch webs between cars and buildings. Wasps could pierce thin metal with their stingers. The question is not whether you could kill them. The question is how long civilization would remain functional, and what you would have to do to survive the first 48 hours. Increasing an insect size by 100 times on a linear scale means its body volume and mass increase by a factor of roughly 1 million. That is not a large ant. It is a fundamentally different organism. At that size, the respiratory system fails first. Insects breathe through a passive network of tubes called tracheae. Oxygen diffuses in, carbon dioxide diffuses out. There are no lungs or diaphragm. At a length of 30 centimeters, an ant would suffocate within minutes. But let's assume the biology has already adapted. Let's say the oxygen delivery problem has somehow been solved, the same way it was during the Carboniferous period 300 million years ago, when atmospheric oxygen reached 35% and dragonflies achieved wingspans of 70 centimeters. Insects have one advantage that large predators do not: numbers. There are around 20 quadrillion ants on Earth. That means there are billions of them for every human being. If this happened, what would these organisms actually look like, and how would it affect our lives? At a body length of 30 centimeters, the anatomy remains ant-shaped, but the physics changes completely. If they became 100 times larger, they could break through doors, shatter windows, and enter through ventilation systems. Walls would not be a real obstacle. But then come the mosquitoes. A mosquito the size of an eagle would not just be irritating. Its proboscis could pierce skin deep into muscle tissue. A swarm of insects like that could drain a human being within minutes. Night would become far more dangerous than day. Spiders would be a different type of problem. A web the size of a street could stop a motorcycle or trap a person within seconds. Some species could build webs between buildings or across narrow passageways. Cockroaches would likely become the hardest to eliminate. They already survive extreme conditions. Larger versions could live in sewers, basements, and collapsed buildings for weeks without food. And wasps would probably become the reason people no longer go outside during the day. An insect the size of a dog, flying at the speed of a car and reacting aggressively to movement, would essentially be a living drone with a stinger. Researchers who study insect biomechanics estimate that an enlarged arthropod exoskeleton would become significantly thicker relative to body size, likely resembling the armor density of a large crab. The mandibles are where this becomes clinically obvious. The bite force of a 3 millimeter ant is roughly 300 times its body weight in some species. That means a 6 centimeter mandible powered by scaled-up muscle mass would exert enough pressure to pierce standard residential materials. The legs create a separate problem. 6 legs of that size, each ending in adhesive pads and tarsal claws, mean the insect would have no difficulty moving across smooth, vertical surfaces: glass, painted concrete, metal doors. The first few hours would be the most important. At first, most people would think these were isolated incidents, but then power and communications would begin disappearing. Ant colonies would emerge from beneath sidewalks and house foundations. People would first notice cracking ground and unusual vibrations. By the end of the day, cities would become dangerous. Supermarkets full of food would attract colonies. Sewers would become the ideal habitat for cockroaches, while streetlights would attract massive flying insects during the night. The biggest mistake would be waiting, and those first few hours would determine who remains inside a safe zone and who becomes trapped. Height would not help. Ants move across vertical surfaces just as efficiently as horizontal ones. Many insects can climb walls, glass, and metal. An apartment on a higher floor is not safe if the insect can reach the building. Isolation becomes the most important factor. Food must be completely sealed, trash removed, smells reduced to a minimum. Ants follow chemical trails. If an area smells like food or organic waste, you become a target. Water is the second factor. Ant colonies require access to water. During drought conditions, colonies relocate. A location without accessible fresh water within foraging distance becomes a low priority area for long-term colony presence. The third factor is sound and vibrations. Ants detect vibrations through their legs. Consistent low-frequency mechanical vibrations disrupt communication and foraging behavior. Industrial fans, generators, or HVAC systems running continuously create vibration profiles that interfere with trail following. Open areas would be safer than enclosed ones. Forests, basements, and sewer systems would become insect territory. Vehicles are not safe shelters. Rubber seals on standard car doors do not create a chemical barrier, and sheet metal does not stop colonies that operate through pheromone trails from feeding. Basements create a false sense of security. Underground environments are where the colonies originated, and proximity to the soil means proximity to the colony's natural habitat. Staying in groups would create an even bigger problem. More people means more heat, more scent, and more noise. Biology does not guarantee survival. It only tells you which decisions are grounded in reality and which are just hope. Humans are used to seeing insects as small and harmless, but insects already dominate the planet in numbers, organization, and adaptability. They do not need to become smarter than us, just bigger.